About a year ago, I came across a really interesting feature on Pluto where these cracks come together called the spider. At the center of these cracks there is a cryovolcano. You can see the mouth of it pretty clearly and the sloping sides. This entire area is like bulging at this central point where there was subsurface pressures that pushed up and created this little cryovolcano at the center or the mouth of these cracks. This led me to a whole different discovery of cryovolcanoes on Pluto, the next of which was what I call the Five Sisters. They are right here, 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 and at the bottom down here. Looking closer, you can see that these are little openings with material flowing down at the sides. This is nitrogen coming out the mouth of these volcanoes. They look very similar to Iceland's volcanoes that are lined up along a fault line. This too is a fault line on Pluto. A fault line of sorts. It's more of a compression area. It's a compression area along here, and you can see this ridge line that's been pushed up against the whole landscape. This is all bedrock ice, water ice. This is nitrogen ice, which is in a viscous state. It's like toothpaste consistency, or cold honey, or molasses when it's cold. And this fluid is pressing up against this land mass, which has collapsed this one edge here, creating a pressure zone where these volcanoes exist. That then led me to another more interesting volcano, which is like a bullseye staring everybody in the face, but nobody's identified it yet as a volcano. But if you look at it closely, it clearly is a volcano. You can see the mouth, you can see fluid, nitrogen fluid, flowing down the sides, creating this caldera or lake of nitrogen. And the reason I know that this is an active volcano is because if you look at a nitrogen map like this in yellow, you can see the nitrogen that's all over Sputnik Planitia here, but right here in this area is Elliott crater, and you can see nitrogen is coming out of Elliott. There is no nitrogen in the surrounding bedrock ice that's covered in tholin, but in this one spot where there is a peak or a volcano, there is a dot of nitrogen coming out of the mouth and flowing down its sides. This led to another discovery, which is this volcano right here, which I like to call bread slice because it looks like a slice of bread. And there's the mouth of the volcano and the nitrogen fluid that's flowing down the sides. In this image, bread slice is right here. It's like a little bullseye. The other series of 5 volcanoes that I call the Five Sisters are lined up right in here. It looks like there's more nitrogen at the southern portion of these string of volcanoes and less nitrogen, so the more active zone is down in the south of those 5 strings of volcanoes. This is bread slice, this is Elliott crater. So what you can see about this entire area also, this is called Viking Terra, this whole area here. This bulges up in the center. This whole entire region is lifted up, and you can tell that in an elevation map, and the edges are lower, and you can see how the tholin is sort of running down towards the edges. And at the northern portion of Viking Terra you have a series of expansion fractures. At the southern area of Viking Terra you have an expansion fracture, so you've got it bounded by expansion fractures, you have a series of 5 volcanoes lined up over here with a compression ridge up into here. You have a cryovolcano at Elliott right here, bread slice here, and this whole area is a cauldron of activity. But that led me to another cryovolcano, which is right here, and I'm calling this one Kilauea, because spilling out the side of this cryovolcano is a vast lava flow of Pahoehoe lava. Pahoehoe is named after, in Hawaii, after a specific kind of lava that flows out of Kilauea. You can see that this is the mouth of a volcano. In the center there is this collapsed area. There are ridges with where material has flowed down the sides. This is an old dormant volcano covered in tholin. This up here, bread slice, is an active, currently active volcano, cryovolcano, and this is the Pahoehoe lava that has come out the side of this volcano, pushing all of these land ice blocks out into and deeper into Sputnik Planitia. When you look at this area as a whole, it's hard to deny or ignore the fact that this whole area is under pressure. It's causing the central area to bulge outward. That subsurface pressure of nitrogen is also creating these expansion fractures. It's creating this active volcano here at Elliott. It's creating the bread slice volcano, and it's also has created in the past this dormant volcano that I'm calling Kilauea, with this Pahoehoe that pushed out into Sputnik Planitia. This is what Pahoehoe looks like on Hawaii. It also looks like this. It has these ripples, like folds, almost like drapes. And on Pluto, you can see that same characteristic trait in this Pahoehoe field, where it has these ripples in it as it pushed outward. Here's a close-up of Elliott crater. Pretty high resolution. You can see there's another dormant older volcano off to the side. Well, this whole image has been rotated to the left 90 degrees, so this volcano right here would be normally up here. This is the fracture, and the fracture in the normal image goes across the top like this, but I've rotated the image because I like the way it shows the mouth and the volcano and the way it's flowing, the material's flowing out of it. One common feature seen on volcanoes are these striations that come from the mouth of the volcano and run down to the base. These erosion patterns are very common to a volcano. In contrast, those features show up in places like Elliott, the Spider, the Five Sisters. The bread top doesn't look, or bread slice doesn't look quite as much like that, but you can certainly see how there's material running down the sides with a peak in the middle. In contrast to that, this is the mainstream media's cryovolcano, which looks nothing like a volcano. It has circular ring patterns around it. It doesn't have vertical striations going down from the mouth down to its base. This is not a cryovolcano, and in the next video I'll explain why in detail.